so in this video, what we're going to look at is how we, as humans, evolved into being endurance athletes. And before you watch this video, what I'd like you to do is go to YouTube and watch the video in this link here. I'll also post the link in Canvas so that you can see it there, because this is really going to be a really good demonstration of what we're going to talk about today. All right, so the idea that we evolved to be endurance athletes, we talked in the last video that what we have to be able to do is we have to have a pressure, and that pressure was scarcity of nutrients in a hot environment. And now what we have to do is, so that's the pressure, so now what we have to do is we have to have genetic diversity, where all of the different organisms look different, and function differently. And then what's going to happen is the one who is able to meet those demands, overcome the stressors, is going to be selected for. They're going to produce more offspring, and that's where we're going to drive what humans are going to become. All right, and so the gist of this is, as the video you just seen in YouTube showed you, is that humans evolved this habit of persistence hunting, and persistence hunting allowed humans to get a huge amount of food because they could now take down all of these different species here, listed here, which are different antelopes. But if we're just going to go and we're going to try and grab an antelope, as we talked about in one of the first videos, we're not fast enough and we're not strong enough, and they will destroy us. So what we did instead is we would chase them a little bit, they would sprint away, we would continue to chase them and continue to chase them. And because it's a very hot environment, we don't have as much fur, we have a couple of other adaptations. We have all of these other things that make us better endurance athletes, take less energy to do this, and we just keep running after them. They sprint away and rest, sprint away and rest. But because we're able to pursue them in a constant manner, they don't have enough time to rest. So by the time that we finally catch them, and you can see here that an average persistent hunt lasted between 4 hours and 7 hours. By the time we actually get up to them, at the end of the 4 hours, that animal is actually very, very fatigued, very overheated. They cannot regulate their temperature as well. And so now, even though we're not super strong, we are stronger than this animal that we've been pursuing for 4 to 6 hours. So that's the idea behind persistence hunting. And because you could go out, and if you could go for long enough, you could take a very big, strong animal and overcome it, because that big, strong animal has been broken down by their poor endurance. That is actually one of the things that helped us survive and was evolutionarily selected for. So a lot of the things that we look for in humans are things that are going to improve us as endurance athletes, specifically as endurance runners. Even today, the Western States 100 that is run up in Auburn every year, that was always a man versus horse race, because the idea was that if you make the run long enough, men or women are actually faster than horses over a greater distance. And that's true both in this race, the Western States, but there's also a number of other races around the world where what you do is you make the race as long as possible, and now humans begin to have an advantage. So how do we get those advantages, and what do we get selected for? So the human advantages are this idea of thermoregulation, heat regulation. So we don't have any fur. We instead of hair, because we have hair, we have sweat glands. And the other thing that we've got instead of being quadrupedal, we're bipedal. We stand up, and that's really important, because when you're standing up, the sun doesn't hit you as much, and the wind does hit you more. So you're able to get rid of more energy, more heat using the wind, and you don't absorb as much energy from the sun. The second thing is we've become really a much more economical runner. It takes less energy for us to run than it did for our ancestors. And the adaptations that we made for this, we have shorter toes, because the longer the toes, the more energy it takes to push each time. So by shortening the toes and making the bottom of the foot into these ligamentous structures instead of being muscles, we lose the ability to grip with our feet, so we can't grab a branch and we can't climb as well. But now we can store energy within these tendons and ligaments within the feet that are going to really allow us to use less energy to run. And the last thing is we have smaller muscles, shorter muscles, and the shorter muscle with a longer tendon, the tendon stretches and recoils just like a spring. And when it does that, it doesn't cost us any energy. What costs the energy is making that muscle contract. So if you have big, huge, long muscles, it costs more energy than if you have shorter, smaller muscles to run. And that's an advantage. So here are the thermoregulatory advantages. If you take an individual who's a quadruped, like greater apes, what you can see is they're more exposed to the sun. The sun coming down is going to have more surface area on which to absorb. If you take a bipedal animal, there's less solar absorption of energy, and you can see that there's more wind. Because you've got more of your body exposed to the wind, you can dissipate heat more, and because you've got less exposed to the sun, you can absorb less. And the other thing that's really important is that because fur, in the last video I brought in Roxy, my dog, she has got fur. So what does she do when she gets hot? She starts to pant. And she starts to pant because that's the only way that she can dissipate heat. She doesn't have these sweat glands that we have in our skin associated with our hair instead of our fur. And having sweat glands allows for us to lose water out onto our pores, and then it allows this wind to take that water off of us. And as the wind takes the water off of us, it takes heat with it. So that's a huge advantage. Those two things are huge advantages. And then as far as our running economy, if we look at a greater ape, you can see that they've got long digits in the foot as well as in the hand. And these long digits in the foot allow them to grip and climb trees really, really well. But if you look at a human, we've got very short toes in relation to what you would see in an ape. And what you can also, you can't see it here, but you know it because there are all of these structures at the bottom of the foot. And we call it, when they hurt, we call it plantar fasciitis. And what it is these are all these tendons that when we load and we put pressure on the toe, what happens is now we're going to load the spring within our foot and we get free energy back. And if you look at our muscle mass relative to say, a chimp or a gorilla, what you can see is that these animals have much, much bigger muscle. And it's much, much longer. It goes much closer to the hip all the way down to the knee. In humans, what we have is our muscles are shorter, they're smaller, and this is especially true in the hamstring muscles and in the calf muscles. And those are muscles that allow us to run effectively. So again, one big advantage is that we have smaller muscles that are shorter because the energy that we need to run is coming from actually contracting the muscle. So if we have less muscle and we have more tendon, we have more free energy and less metabolically costly stuff. So if we look at this now and we look at how we walk, this is how much energy it takes to walk, and this is how much energy it takes to run. And what you can see is that everybody knows this. If you're going to the mall and you're walking really, really slowly, God, you get so tired. And the reason for it is that it's energetically less efficient to walk slowly than it is to walk moderately fast. But we've also been late for something. And when we're late for something, there's this idea, well, we'll walk really fast. But it actually costs more energy to walk really fast than to run at the same speed. So that's this transition where we go from walking to running. When you get to this point here where it costs more energy to walk than it does to run, it makes more sense to run. The really important thing for humans is that it doesn't cost us much more energy to run fast than it does to run slowly. And that's because we're storing energy in our tendons and ligaments. If you look at a quadruped like a horse, they have 3 transitions. They go from walking to trotting to galloping. And you can see that the walk, again, just like a human, has this U-shaped curve. The trot, you can see how much, this is their run essentially. You can see how much more energy it costs, or how much more energy it costs to run slowly than it does to run fast. And the interesting thing here is that this is the point where most humans run. We're running in this region here, and that's right at the transition for most quadrupeds between the trot and the gallop. If you ever run with your dog, you can see that they're trying to decide whether they should trot alongside or whether they should gallop alongside. When you go a little bit faster, they'll gallop. When you go a little bit slower, they'll trot. So you're right at this transition that costs them a lot more energy. It's like they're trying to walk really fast. And when we're doing persistence hunting, we were able to chase them at this speed where they're trotting too fast or they're galloping. That's energetically more costly for them. And even though their curves are lower than ours, that's because it's regulated by body size here. If we go and we look at and we take a 500 to 1,000 pound horse versus a human, now these numbers are much more similar. So it costs about the same amount of energy. So the response here is that when we're doing persistence hunting, we're running at a moderately fast speed. That's at this transition point for most quadrupeds, making it really, really hard for them to maintain that speed as efficiently as a human, because now what we're doing is we're storing and returning energy within our tendons, and because we're upright, we're less exposed to the solar energy and we have more wind against us so that we can cool more easily. And when you put that together with the fact that we have hair and not fur, and we have within our hair, we have these sweat glands that allow us to dissipate heat, now we've got a big advantage for being able to get nutrients in a hot environment.